In this video, we will talk about how to evaluate trigonometric functions given a point. So let's say we're given the point 4, 3, and we want to evaluate some trigonometric functions related to this point. So it helps if we first draw the point. So let's go ahead and draw that on a coordinate plane. So if we've got our x-axis here and we have our y-axis here, the point 4, 3, so that the 4 represents the x. So 1, 2, 3, 4, and the point 3, the value 3 represents the y value. So we'll go up 3. So the point 4, 3 would fall right about here. Now, let's go ahead and label that 4, 3. What we can do is we can form a triangle using this point. So we can drop a line straight down to the x-axis from that point, and we can draw a line straight to the origin from that point. So notice how this forms a triangle. What we want to do is find some trig functions related to this angle right here, the angle that touches the origin. So if we have this triangle, we know that the length of this side, the x side, is 4. And we know that the length of this side, or the y distance, is 3, because we were told that. Now, all that we're missing is this hypotenuse, the longest side right here. So how can we find the length of that side? Well, we can use the Pythagorean theorem, which says a squared plus b squared is equal to c squared, where c is our hypotenuse. So we know the a squared and the b squared, that's 3 and 4. So let's fill that in our formula. 3 squared plus 4 squared is equal to c squared. So 3 squared, that's 9. 4 squared is 16. So 9 plus 16 is equal to c squared. So 9 plus 16, that's 25. 25 is equal to c squared. So to find c, we can take the square root of both sides. The square root of 25 is 5. So c, the hypotenuse, is 5. So this side right here of the triangle, this side is 5. So now that we know all three sides, the lengths of all three sides of the triangle, we can find some trig functions related to this angle right here. So for example, let's say we wanted to find the sine of that angle. How can we find the sine? Well, it helps if you remember the acronym SOHCAHTOA. SOHCAHTOA. Where the sine is calculated by taking the opposite side over the hypotenuse. The cosine is calculated by taking the adjacent side over the hypotenuse, and the tangent is calculated by taking the opposite side over the adjacent side. So to find the sine of this angle right here, this SOHCAHTOA tells us we can take the opposite side divided by the hypotenuse. So the side that is opposite of the angle, that's 3. So we'll say 3 over the hypotenuse we just found was 5. So the sine of this angle is 3/5. What about the cosine of that angle? How can we find that? Well, according to SOHCAHTOA, we can take the adjacent side divided by the hypotenuse. So the adjacent side to this angle is 4. And the hypotenuse, we said, was 5. So the cosine of this angle right here is 4/5. Now, what if we wanted to find the tangent? Well, our acronym SOHCAHTOA tells us we need to take the opposite side over the adjacent side. So the opposite side of this angle, it's all the way over here, that's a 3. And the adjacent side is a 4. So the tangent, oops, there should be a theta right here. The tangent of this angle is 3/4. All right, what if we wanted to find something a little more complex, like let's say the cosecant of that angle? Well, if you'll recall, the cosecant is just 1 over sine. So that's just 1 over, we already found sine, that's 3/5. So 1 over 3/5, that would just be the reciprocal, or 5/3. What if we wanted to find the secant of the angle? Well, remember the secant is just 1 over the cosine. or in other words, it is the reciprocal of whatever the cosine is. So we already found the cosine to be 4/5, so the secant will just be 5/4. It's the reciprocal. And lastly, what if we wanted to find the cotangent of the angle? Well, recall that as just 1 over the tangent, or the reciprocal of the tangent. So the tangent is 3/4, so the reciprocal of that is 4/3. So just given the point 4, 3, we were able to find all of these trig functions: the sine, cosine, tangent, cosecant, secant, and cotangent. All right, let's try another example. Let's say we're given the point 6, -8. How can we find some trig functions related to this point? So let's draw this again on the coordinate plane. So 6, so we're going to go over 6 on the x-axis. 6, and then -8 will go down -8 on the y-axis. So the point 6, -8 is somewhere down here. And remember, what we can do is we can create a triangle using this point. So from the point to the x-axis, we'll draw one side of the triangle. And then from the point directly to the origin, we'll draw another side. And we'll find some trig functions related to this angle right here that touches the origin. So we know that this side of the triangle is 6. That was the x distance. And we know that this side is, we'll say, -8. That was the y distance. We need to find the hypotenuse, or this side right here. So once again, we can use our Pythagorean theorem. So we'll say a squared plus b squared is equal to c squared, where c is the hypotenuse. So we'll say 6 squared plus -8 squared is equal to c squared. So 6 squared, that's 36, plus 8 squared, 8 times 8, or -8 squared, excuse me, is -8 times -8, that's +64, is equal to c squared. So 36 plus 64, that turns out to be 100, is equal to c squared. And if we take the square root of each side to get c by all by itself, we find that c is equal to 10. So this hypotenuse right here is 10. So now that we know all three sides, we can find the trig functions. So let's say we wanted to find the sine of this angle right here. Well, referring to SOHCAHTOA, the sine is calculated as the opposite side over the hypotenuse. So the side that is opposite of this angle is -8. And the hypotenuse we just found was 10. So -8/10. And if we'd like, we can reduce that to -4/5. So that is the sine of that angle. What if we wanted to find the cosine? So the cosine of that angle. Well, according to SOHCAHTOA, the cosine is calculated as the adjacent side over the hypotenuse. So the adjacent side is this 6 right here. The hypotenuse we found is 10. So the cosine is 6/10. And if we'd like, we can divide the numerator and the denominator by 2 to reduce that and get 3/5. So the cosine of that angle is 3/5. What if we wanted to find the tangent of that angle? Well, SOHCAHTOA tells us we need to use the opposite over the adjacent. So the opposite is the -8, and the adjacent side is 6. So -8 over 6, or we can reduce that to -4/3. That is the tangent of that angle. All right, now what if we wanted to find the cosecant of that angle? Well, recall the cosecant is 1 over the sine. Or in other words, the reciprocal of the sine. So we already found that the sine is -4/5. So the cosecant is just going to be the reciprocal of that. So we flip the numerator and the denominator. That's -5/4. What about the secant of the angle? Well, remember, that's just 1 over the cosine of the angle. Or in other words, the reciprocal of the cosine. So we found that the cosine is 3/5, so the reciprocal of that is just 5/3. And lastly, what if we wanted to find the cotangent of the angle? Well, the cotangent is 1 over the tangent, or the reciprocal of the tangent. So the tangent is -4/3, so the cotangent would be the reciprocal of that, so -3/4. So we have just found all 6 trig functions related to the point 6, -8.